All right, so here we go. So over here, go and open FEMAP. Hopefully it will be in all of them. And I will try to put the other video because the other video was one that I did a while ago, but it wasn't a bad video at all. It was pretty detailed. I don't know where to put this. Let me put it here down here. So basically, this is FEMAP. We need to create the geometry. So help me a little bit because I don't fully remember the geometry. So our problem of the wing spar, maybe let's try to open the file. Lecture notes, lecture 8. So we're going to be doing this problem here. So basically, let's see we did all this stuff is the 30, then we did the example. So let's see, the example looks like it's 2 meters. All right. So 2 meters, 0.4 and 0.2. Okay. So let's see, if I do this one, the middle will be, all right. So if I do this point from the middle, will be geometry points. Let's say I do one at 0.2. Okay. I do the other one at negative 0.2. How can I eliminate this stuff? Okay. So I have 1 point here, 1 point here, no? Now we can move to 2 meters. Oh, so I'm doing everything in meters now. Okay, that's fine. So we move to 2 meters, x equal 2 meters. And at the tip, I think was 0.2, no? So we can do 0.1 on top, 0.1 at the bottom. So 2 meters, we do 0.1. Okay. And negative 0.1. And if you click Control A, this should center everything. All right, so the next thing we're going to do is we're going to create the panel. So again, I haven't done that in a long time, so I might not be. So surface, corners, and here you can come and select methods, I guess, on points. And you click 1 point, enter, 1 point, enter, 1 point, enter, 1 point, enter. And I guess, okay. Oh, cancel. Okay, so it looks like here we have the geometry. Let me do something. Save us. Sure. Then AE418. Summer, so let's say, so wing spar. Case 1. Okay, so, all right, so here let's go now to, there's multiple ways to do this. You can open here the model. If you click on it, then you can right click here on the material, new. So I think here we're using a metric unit. So if you want, I know this is about really 72 to the 9 gigapascals for property of aluminum. So that should not be important because we are not looking at deformations, just looking at values. So you can really put whatever you want. You want to put 1, this would be fine. I just try to put more realistic values. This is like for aluminum. If there were English units, you can load from here different properties, okay? You see, those would be English units. So because it's metric units, I just put this, you click OK. So first thing to do always to define the material. Okay, you can have multiple materials. Okay, if you double click on it, it will become bolted. That means that this is the active. Now we go to properties. So to properties, you can right click and say new. Okay, for case one we say is when the panels are not effective in carrying any bending moments. Okay, so they do not resist any bending moment. So the right way to model these panels will be you go here to element property type, and you will go to shear panel. Let's see what that is. Again, I haven't done that for a while. So shear panel, you come right here. Okay, you click this one. I don't think that's important. You can just put 1. Was the thickness given to us?
Yes. 0.05.
0.05. So that will be meters. That sounds too much. What's the thickness? 0.005. Okay, it doesn't matter really, should not matter. Here, what we're going to say is that, so basically what happened is that this constant over here, effective factors, are basically like they say, you want to put some, you can say that this is surrounded by some rods, and you can put the stiffness over here. But I've never been able to run it too good, so generally I put very small values over here. Hopefully it's going to work. Okay, again, I haven't done that for a long time. And I think here I should even put 1. I don't know if it's going to change something, but it doesn't matter. We can always change it later. And put over here, okay. All right, so we have the first property. So this will be modeling the panels. Now, what I want to do is model the flanges, okay? The one at the top and the bottom. So we need to do all around. So I'm going to do now, so we're going to model that with rods. So if you go here to properties, you should have the shear panel. You right click on properties, new, you go to, again, to element property type, click rod. If rod doesn't work, we can select something else. What was the area? Was it 400? I don't remember. Yeah, 400. So be careful here, because 400, if we do that in meters, how much should that be? So it's 10 to the 3 now, but it's square. So we need to put that what to the nearly 6, no? All right. So it says will be rods, or I mean, for flanges. We do this one. So I will click OK. Cancel. So we have 2 of them here. Okay. Now we need to go to mesh control, size along curve. That's the way I'm going to do it. Okay. So let's select first the two at the end. Click OK. And it might be too much. Let's put 8. Okay. Okay. And now you click the one at the top and the bottom. No idea how many you want to put on this one. So we put 8 on this one, which is 0.4. 20. All right. 20 might not be enough. I mean, we can always change it. So what about 4? Is that okay? Might be too much. We can change it. That looks about okay, no? And cancel. Okay, so now what we're going to do is we're going to come over here to mesh, geometry, surface. Are you going to select the only surface that you have? You click OK. And we're going to mesh this with the shear property. Okay? Okay. You see, it looks pretty cool. Sorry? Geometry, yeah, mesh geometry, then surface. Now we do the same thing, mesh geometry, curves, and let's select the 4 of them. Click OK, and this time we're going to mesh this one with the property flanges or the rods, and click OK. All right. So now this is the part we need to go to tools. I guess we need to go a little bit more down. Check. I think you did this for the other one. Coincident nodes. Select all. Okay. Review, and that makes sense, no? you need to connect all the flanges that we put around to the shear panels, no? Yeah?
Can you repeat that last step? You said,
Tools,
yeah.
check, but it's all the way down. Coincident nodes, select all. I'm on preview, so that makes sense, no? Now we are connected all those flanges, no? That around to the shear panels. And I guess you can click done. Okay. And that's it. Now we need to apply the, let's say, the boundary condition. So let's say here you go to model, constraint. Let's see, we do on curve. You have different options. Let's say on curve. You can say here, whatever, clamp, fix, or not put anything. Generally, I don't put anything, but fix. We select the line on the left edge. And we click OK. And we say fix, okay? So you should have some little F showing up over there. And we close this one. So now what do we have left to do? We have left to apply the load. So there's multiple ways to do this, but let's do the simplest way. So model, load, let's say nodal over here. And if you want, put F equal, if I remember right, that was 20 kilonewtons. You click OK. And here, try to select the one that will be in the middle. If you do control, you can just move it on that direction and then roll it. Okay, so that one looks like it's that one here is like 1, 2, 3, 4, 1, 2, 3, 4. I select that one right in the middle. I click OK. And where was the force going? Up or down? Down 20 kilonewtons. So we can put here minus 20 to the 3 if you want. We do this that way. Or we put minus 20. Newtons millimeter square. I mean, let's do it this way, and then we can change the units at the end, no? The motor. Here we go. All right, so I think that will be it then. So, okay. Okay, what is this? Well, no. So cancel, Control A to center everything. I think that's all we need. I like to do this over here, but you don't have to. File, rebuild. Yes. We're going to save. We're going to go to the 2 gears over here. That is analyze. We're going to create edit new set. New, static. Click OK. And analyze. And hopefully nothing will happen. So here we go. We have this. Now this is the part now I'm not going to be sure that I remember properly. So, okay. So it run. All right. But we want to have the results. So, I mean, let's go here now. You can click off F5. I don't know which one we need, really. F5. You can go here to deform. Let's see, contour. What do we want? Oops. So I think it's the last one. Shear panel, shear force average. I think it's the last one. You click over here. Don't put any deformation. Just put this. And OK. And I guess contour, but OK. And this should give you all the values for the shears in the panels, no? Okay. But we did a calculation at 1 meter. We're just interested with the one at 1 meter, no? Okay. So what you can do here, maybe go is that tools. Click on work plane. Click on draw work plane. Done. and that will give you a scale. So in order to see the results over here, I mean, you can go here per color if you want, but let's see what you can do. Oh, it's one over here. So scroll down over here, go to groups, right click, new, whatever, say cut, whatever, 1 meter if you want. I mean, whatever you want. Click OK. Now we go to groups. Group element ID. Here on the peak, click on peak, select box. And now you come here close to 1 if you want, okay? You click and you keep your finger on the mouse and you kind of select these elements that will be right about 1. So you double click, you see it's going to take these ones. And you click OK. So now when you go here to the group, this should have created a group. If you double click on it and then right click and say show active group, it should just show you this one over here. Okay, so you see it's not really much of a difference between 43, 44, but if you want, you can click F5 at this point and say criteria. And obviously it's not going to be perfect because we should take a much more mesh. But basically you see that these values are more or less constant now, which is what we needed to find for the case 1. What do we find for case 1 yesterday? So I think it was the last one we did yesterday, if I remember properly, 48.89, no? Okay, in this case, we find it about, let's say it would be what, 44, 45? All right. The reason, if you take elements smaller, is going to find a bigger value because what is this doing now? This is taking some type of average, no? Okay, so if you refine the mesh, you could probably get a bigger answer. But you see, this is because of the units, it's a factor of 3, no? It should be 43. But this would be one way to check your answers. Okay, for case 1. All right. So case 1 is the easy one. Case 2, I know there's a manipulation to do. I don't remember exactly how to do it. But anyway, any question about this one? So F5, if you want, you can put contour again. And okay, and that's it, no? So let's save that one, file, save. You can remove if you want the work plane to make it look pretty now, so on. If you want, I mean, there's a bunch of stuff you can do. I don't fully remember this. Loads, I think this one. Okay, I don't know. So there was one that you could remove. This one, you remove the nodes, I think. I mean, I don't know. I don't know exactly what you can do, but you can remove the nodes. You can make it look pretty, no? If you want. All right. So we can do save. So now let's do file, save as, and instead of case 1, let's say case 2. And that one, I remember how to do almost everything, but not the output part. But I'll probably find something where I can look at it, okay? So, okay, so what we're going to do is results, go to results over here, right click and say delete. All right, preserve, undo. And just for safety, we could keep it, but just for safety, I'm going to delete also the analysis. What would that be? Results, analysis. You can open the analysis, right click, and again, delete. Okay, so over here, what we're going to do is replace. Now we do case 2. So case 2, we still have the flanges. represented by the rods. But now, what is the difference between case 1 and case 2? In case 2 now, the skin should be effective in resisting bending. Okay, so shear panels are not good for resisting bending. Okay, or maybe let me open the other one. Maybe I should have done something very quick. If you go to F5, hopefully it's going to do what I think, and you click deform. Okay, so it's doing the right thing over here, but sometimes it doesn't do it for 3D. But you see it's deforming. Okay, that's good then. I thought maybe it was going to do something else. So let's close this one. Oh, we can leave it up. It doesn't. Let's go to this one. So we need to replace the shear panels by plates. Okay, so we could delete everything and redo it, but maybe what we can do is just come here to properties, click on new. We go to element property, plate. Okay, and what was the thickness? You told me, I remember, but 0.005. Is that what the thickness is?
0.05 millimeters. So what was it?
Oh, I don't remember. So it would be, how many millimeters is that? 0.5 millimeters? I mean, what is the problem statement saying? Okay, let's look at this. I think we had it here, no? Wait, somewhere here. See, it's 2 millimeters. Why was it 5? Why did you say 5? I mean, that was probably the change on the other one, okay? So it's 2 millimeters. So, okay, so will be 2 millimeters, will be 0.002. Yeah, okay. So, okay, we have the property. Let's go back to the other one, case 1. Sorry for that to go back and forth, but maybe that's what is going to be give the little difference. Let's delete the results. So you go here, all results delete. You can keep it if you want. Preserve, undo. Let's go here to model. You open property, you open shear property and edit. And let's put over here 0.2 instead of 5. Click OK. File, rebuild. Yes. Save. And the little gear over here, click on it. All right, so you did it. You close this one here. We can come back now to groups. Double click on it, right click, show active group. And you see it didn't change much of results at all, no? So that wasn't really the issue, okay? We still have about the same values. But at least we know that we did correct. Okay, so now let's go back to case 2, okay? Sorry for that. So now we have 3 properties, the plate and the shear. Okay, so something we can do over here is we can go here to, I think it's tools. Hopefully I know how to do this. How do we do this? Section property. No. Mass properties. Let's see. Machine toolbox, no. Okay, so maybe check. Oh, maybe it's this one. No. Surface property, mesh property. I know you can replace one elements by others. Okay, let's try this one here. Section property, mesh properties. So let's do here method by type. They should have type, shape, property ID. Property ID, can do that one. Property ID, what is the property ID that we want to change? Is the shear panel? Oh, So 1, we can maybe do something else. Okay, hold on 1 second. Let's come over here. Let's eliminate the flanges. Okay, and we do the same thing. Tools, section properties, mesh properties. Let's say select all. So it will be all these elements here. Okay. Oh, no. That's not what I want to do. How did we do this? Okay. Okay, guys, sorry for that. So basically it wasn't on tools, it was on modify, which makes sense. Update elements, property ID. So we're going to modify the, let's see, by here we can say by property ID. So the 1, we're going to change the 1. More, so select elements property by property, okay. And now we're going to put select property to update, we're going to put 3. Why does it want to put 3? So don't let you do this. Okay, 3. See if it let you do this. Okay. I don't know why he did it. Okay, so we can check with this. So these ones are gone, and this one another. So it hasn't done it. This used to be easy. The elements.
I think you have to right click on the property and put edit.
Okay, but it's over there. But yeah, maybe you're right. So property by type. By type, let's see that one. So select all. Okay. And now I want to change that into plates. Let's see that will work. Okay, so now all the shear are gone because you see they are selected here, they are not showing, no? Okay, so if I deselect, should not show anything. If I select, now it shows the plate elements. So sorry for the confusion. Have you been able to do this or not? So you go to modify, update element, type. Okay, you want me to keep going or have you been able to do it? I mean, maybe it would have been easier just to delete and restart from 0, no? But like I told you, it's probably a couple of years I haven't used or haven't do this one, okay, or even more. Have you been able to move to the plates, the people that have the laptops? Yes? Okay. So here you can go file, rebuild. Oops, I don't know what I did here. File, rebuild, yes. So we can save. And we can analyze. Create, new, static, okay, and analyze. Okay, it finished. So now the problem of this is that if you go now to F5, okay, and you go here to the stuff that you can plot, that you can show, he has a lot of stuff over here, but nowhere is going to show the shear stress, but it's not going to show the shear flow. Okay, so we need to get around that problem over here, and that's the part that I know you can take a stress and multiply by the thickness, so you get the shear flow. Can we get the shear force? But then it's per unit length. Okay. So let's put here. Let's say you put the stresses. Okay. All right, cancel. So cancel for this for now. And let me pause this for a second. stop the recording. So, okay, so let's go back and stop the recording. So I think that let me delete this one. All right, and restart from here. So F5, we're saying that because the output now it changed this one, cancel. So deform, criteria, contour. Okay, because here we don't see the shear flow, we need to use the shear stress. Oh, this is the stress. We need to use the shear stress, top shear stress, this one here. Okay. And basically this gives you the shear stress, which is force per area, no? Okay. And what is shear flow is force per unit length. So what we need to do, like we're saying here on this document, is that we need to multiply the shear flow basically by the thickness, by what would be T, okay? So in order to do that, what we need to do is F5, deform contour. Looks like here you needed to go to, was it output? You see, I forgot already that stuff. I think you need to go to model output process. So you go to model, output process, linear combination. We're going to multiply this one by 0.002, which is the thickness of the panel. Now select output to process. So this should be good. So I don't know why it doesn't let you to select just one. Looks like we're going to have to multiply everything, but for this case, it's going to work. Should give you the option just to select one case. Let me see if just, let's see if that will do it. Yeah, that will do it. You see, now you can only select one, which is would be the only one I want to select is the shear stress, top shear stress. Where is it? Here. Okay, 7031. Yeah, that will be the one. And we click now, okay. And okay. Okay, say yes. I don't know what happened over here. We need to go here to the combine. And now it's not showing anything. So contour output vector does not exist. All right, so it worked before, now it's not working. Okay, so let's delete this one. And let's do the same thing that we did before, preserve, undo. So model, what was it? Output, process, linear, 0.002. Select output to process this one. Okay. Okay. So, oh, maybe it's because these ones are not there. All right, so this is the results. So basically we come over here and it did multiply it. And now you see this one went a little bit up, not even. It's about the same value that before. If I do F5 to criteria. And here we're going to get about 53, which is the same thing as before. Okay. All right, so file and save. Any question about this FEMAP? Two of you asked me that they were interested in learning more FEMAP. So this would be the way to learn more, no? Okay. The good thing is that you should be able to check your answer. But what's important over here is that you understand the assumptions that you need to do for the modeling. So let's see, let's go back very quick. For case one, what is case one? Is that the panels, so the skin is not effective in resisting bending. Okay? So when something is not effective in resisting bending, you need to do the modeling of the skin by using shear panels. Basically means they cannot resist anything except that is. So basically they don't carry they don't resist any bending moment, okay? All right. If you want the skin to resist some of the deformation, so let's look at this one. Let's see if it will work or not. So I don't think it will be much difference, but let's say deform, maybe might not be any difference, but because it's too small. Okay. How much is the deformation here? The maximum 0.00331. Okay. So the deformation due to the bending, if it's only resisted by the flanges, it's 0.00331. All right. Now, if we go to case 2, now case 2, what did we do in case 2? If you remember, when we calculated the I, we took into consideration the thickness of the panels, no? Yeah. So let's see. Probably it's too thin, the panels. Here I multiply everything by 0.002, so it's not going to work. Should give me a nightmare, but maybe we can remultiply. If we do F5, contour, deform. It multiply everything by 0.2. Oh, maybe not. So hold on. Nastran case 1. This is without multiplying anything. So if the thickness is adding something, okay, here multiply something, but it's instead of 0.0031, is 0.0263. No, you see over here. Does that make sense or not? The panels now are resisting bending, no? So they offer more resistance to the bending. So you see the deformation is 0.0263. And in case